Hello friends, welcome to my non chemistry YouTube channel. I am John Wednesday. Today I am going to discuss typical problem in the textbook and textbook related questions. First problem, in a solid atom M occupies CCP lattice and 1/3 of the tetrahedral voids are occupied by atom N. Find the formula by M and N. Option A Mn, option B M3n, option C Mn3, option D M3n. That is, in a solid atom M occupies CCP lattice. We know CCP, in CCP the number of tetrahedral void and octahedral voids. The number of octahedral void is taken as n. The number of tetrahedral void is taken as double the number of n. That is, here M occupies the tetrahedral. The number of octahedral void is equal to here n. The number of tetrahedral void is equal to 2n. Here n is equal to 1. 1 is to 2 into 1/3 of the tetrahedral void is occupied. So 1/3. That is equal to 1 is to 2/3. That is 3 is to 2. So the correct option is M3 N2. So here solid M occupies CCP lattice and 1/3 of the tetrahedral void occupied by atom N. Find the formula. So here the number of atoms in FCC or CCP, the effective number of atoms is equal to the number of octahedral void, and tetrahedral voids are double the number. So here the octahedral void is taken as n. What about the tetrahedral void? Double the times, but to 1/3 of the tetrahedral is occupied. So totally 2, in that 2n, here 1/3 is occupied. So 1 is to 2 into 1/3, 1 is to 2/3, that is 3 is to 2. So the formula, correct formula is M3. Then second problem, a solid A plus B has body centered cubic structure. The distance of closed approach between two ion is 0.767 Armstrong unit. The edge length of the unit cell is. Here to find the value of edge length. So the in BCC crystal, the formula is usual formula 4R is equal to √3a. But here instead of radius, solid A plus B minus ions form is given. So if ions form is given, then the 4R is written as 2 into, that is very important, 2 into R plus R minus, that's equal to √3a. Then 2 into, this value is given 0.767 Armstrong unit. That's equal to √3 into a. Here important one is, here the important one, here the question is Armstrong unit. Question is given in Armstrong unit, but the answer is picometer. That is very important. So this Armstrong unit is converted into picometer. So 2 into Armstrong unit means 10 raised to minus 10 meter. Picometer means 10 raised to minus 12 meter. So 2 into 76.7 into 10 raised to minus 12. That is, it converted into automatically picometer. That's equal to √3. 1.73 into a. Here to find the value of edge length. So what is the formula edge length here? A is equal to 2 into 76.7 divided by 1.73. Students, you must remember one of the important concept for doing problem is when doing the problem, to see the answer. If the answer is very close to one another, option A, option B, option C, the answer is very close one another, to take all the decimal digit. All the digits are considered for calculation. If the answer is variation, then don't waste the time for calculation, because each question 1 minute. So to take the nearest value. So instead of 76.76, that is 2 into 77 divided by 1.73, 2. So 2 to cancel. So here the answer is 77. So but here there is no 77 in the answer. There is no 77. So but the answer is close to 77. That is their nearest answer is 81. So 81.63. So here the important one is, usually the radius and edge length for BCC 4r is equal to root 3a, but here iron form is given. If it given in the iron form, instead of 4r, 2 into r plus r a minus, then everything is same. But then third step, what is the concept? Here Armstrong unit is given in the question in the Armstrong unit, but answer is given in the picometer. So Armstrong unit means 10 raised to minus 10 meter. It is converted into 10 raised to minus 12 meter. So 0.767 is written as 76.7 into, by doing the prop, then the answer is 77. Here the nearest value is 81.63. Then third problem, the number of unit cell in 8 gram of an element X, whose mass number is 40, has BCC pattern. BCC pattern is Avogadro number is given. Na is the Avogadro number. That is 6.023 into 10 raised to 23. So once again read the problem. The number of unit cell in 8 gram of element is calculated. Number of unit cell in 8 gram has the structure BCC structure. Avogadro number is given. So the answer is all the option containing all the Avogadro number 6.023 into 10 raised to 23. Then here this question is based on the theory part to calculate the density of the crystal. We know mass of an atom, mass of the element, mass of the element is equal to molecular mass by mass of an atom, Avogadro number. Then number of atom is calculated by the formula. Then the number of mass of one unit cell is calculated by the formula. Mass of one unit cell, that is equal to molecular mass divided by n into number of atom per unit cell, that is Z, number of atom per unit cell. This is the calculation for mass. So mass of 1 gram of an element is calculated by the formula molecular mass divided by Avogadro number. Mass of 1 unit cell is calculated by the formula molecular mass divided by Avogadro number into number of atom per unit cell. Here number of unit cell, number of unit cell, that is equal to reciprocal n by molecular mass into 2. So what is the 2? 2 means it is a BCC crystal. Since it is a BCC crystal, the value of Z is equal to 2. Then n 6.023 divided by molecular mass is given 40 into number of atom per unit cell 2. To calculate the number of unit cell in 8 gram. This is for number of unit cell in 1 gram. So 8 gram is multiplied by 8. So here 8 into 45, 5 into 10 into 10 raised to 23. 10 raised to 23. 10 raised to 23, that is equal to 6.023 into 10 raised to 23. 10 raised to 23, here 10 minus 1. So that answer is 6.023 into 10 raised to 22. So which option is correct? And option B is the correct option. So here this problem based on calculation of density of the crystal. That is the middle step, that is the step involved for the calculation of density. Here number of unit cell in 8 gram of an element is calculated. First we know the formula, mass of an element. How to calculate mass of an element? Molecular mass divided by Avogadro number. Then mass of one unit cell. Mass of one unit cell is calculated. Mass of molecular mass divided by n into number of atom per unit cell. Since it is a BCC, it is multiplied by 2. Then number of unit cell. Mass and number of unit cell are reciprocal. So n divided by molecular mass into 2. So Avogadro number 6.023 into 10 raised to 23 into 8 into 8 divided by 40, molecular mass 40 into 2. So why it is multiplied by 8 for calculating number of unit cell in 8 gram. So the answer is 6.023 into 10 raised to 22. Then fourth problem, the ionic radii of A plus and B minus are 0.98 into 10 raised to minus 10 meter and 1.81 into 10 raised to minus 10 meter. What is the coordination number of each ion? Here calculate the coordination number. We know the number of close neighbors. The ionic radii of A plus is equal to, ionic radii A plus is equal to how much? 0.98 into 10 raised to minus 10 divided by ionic radii of anion 1.81 into 10 raised to minus 10. So 10 raised to minus 10, 10 raised to minus 10 cancel. This is simply taken as 98 divided by 181. 98 divided by 181. Approximately 1 by 2. 1 by 2 is equal to how much? 0.5. 1 by 2 is equal to 0.5. Then the range we know 0.155 to 0.225. The coordination number is 3. 0.255 to 0.414. The coordination number is 4. 0.414 to 0.732. Coordination number 6. 0.732 1. The coordination number is 8. Here the first to find the value. How to find the value? The radius of cation. Radius of cation divided by radius of anion. Then to find the value. This value ranging from, that is 0.5 in between 0.414 and 0.732. So here this is the coordination number 3. This is coordination number 4. This is coordination number 6. So the option is C is the correct option. Coordination number 6. This type of problem is also very important. Then fifth problem, if A is the length of the sides of the cube, the distance between the body centered atom and one of the corner atom. Here very important is A is the length, edge length of the sides of the cube. the distance between body centered atom and one corner atom. This distance between one corner atom to another corner atom through the body diagonal. This is body diagonal. This is how much? Root 3a by a. Root 3a. Here the question is body center to one of the corner atom. That is half. That is root 3a by 2. So the answer is root 3a divided by 2. Students, you must give less importance to the theory part and more importance to physics, chemistry, problem part. That is, first you should just understand the concept given in the book. By using that, solving problem by practice again and again. That is very, very important. By practicing the problem again and again, that will increases your confidence by facing competitive exams like NEET, JEE and other exams. Also, you will get more depth in subject. I hope you like this video. Thank you for watching.